kick off with Jay, if he's ready.
I can be.
If you want, yeah.
Yeah.
Okay.
Let's do it.
I'll stop sharing my screen.
Okay. Let's see. I don't use Zoom very often, so let's hope that I can share correctly. Okay. We seeing me?
Yep, that's good.
Okay. So hi everyone, I'm Jay Bell. I'm an Angular GDE. I'm the CTO and co-founder of a social enterprise here in Canada called Charles.org. We build software for charities, built an all-in-one fundraising platform. I'm an open source contributor. I love NGRX. I contribute a lot to NX. Haven't actually ever contributed to Angular, funny enough, but I have built a lot of things around and within the Angular space. And I'm a lover of beer and Magic the Gathering. So if you like both of those things, you should follow me on Twitter and send me a message and tell me you love both of those things. So today, what we're going to be talking about is running the Angular service DI layer within a web worker. So first off, what is a web worker? Well, from MDM, web workers are a simple means for web content to run scripts and background threads. So what this essentially means is because JavaScript is single-threaded, you can spin up web workers to do work in the background. So it's an entirely different process, and it doesn't render block your UI. You can make API calls, connect to sockets, do all kinds of stuff in web workers, and then send that data back to your main thread for processing. So if anybody's ever used the Angular service worker, that uses a service worker, which is very similar to a web worker. And then some libraries use web workers, like Builder.io has been releasing a lot of stuff recently, like PartyTown for optimizing, analytics scripts and stuff like that. They use web workers to offload all of the analytics script tracking, all of that kind of stuff into a web worker, and that's how they speed up your site, by causing those tracking scripts to not block your main thread. So that's what a web worker is at a very high level. Now, why would we want to run Angular inside of one? Because we can, really. It kind of started out as just an experiment one day, just to see if I was able to do it. Turns out you can. I don't really know what the use case necessarily is for it, but it was fun to figure out. So we're going to kind of walk through the steps today of what it takes to bootstrap a normal Angular app, and then try and follow that process through, but inside of a web worker rather than inside of the the browser context. So bootstrapping a normal Angular app, when people build, all of us included, build Angular apps, we're just building an Angular app. We're not interacting with the index.html typically. We're not building apps like we used to pre, single page application type frameworks, right? Where you would have your script tags and you would load different, pieces of code that would add event listeners to DOM objects and all that kind of stuff. But in the end, that's all Angular is doing, right? So we see at the top here, we have the contents of the index.html. This is reduced for brevity and the compiled version that you would get after running ng build. So we would have, the script tag for main.js. So really all this HTML file is doing is, when it's loaded into the browser, execute main.js. Simple as that. Inside of main.js, this is where there's that actual code to bootstrap your, typically what's called the app module. You might have it renamed for some reason, but in new workspaces, it's generated as app module. So below here, we can see what the app module looks like. We have that bootstrap component, we declare it. And then in our main.ts, which is the entry file for our application. So for libraries, the entry file is typically like the index.ts, but for application, it's generated as the main.ts. And this code is what's actually executed when that script tag in the index.html is loaded. So we call the platform browser dynamic function, which is supplied by, I believe it's Angular core. And then once that returns, it returns a platform ref. We'll discuss what platform refs are a little bit more afterwards, but it exposes a function called bootstrap module. And that's where you pass in your app module, which does all of your configurations. It global imports, your for root methods, global providers, injection tokens, all of that kind of stuff, right? So that's what bootstrapping a normal Angular app does. So let's kind of like drill down into this a little bit. So this code is taken directly from the Angular code base. You can see in the comments what package it's from and then the file if you want to go look it up yourself afterwards. So the platform browser dynamic is created from a create platform factory function. And it inherits from platform core dynamic. And platform core dynamic is created from create platform factory, which inherits from platform core. But then platform core is our lowest level. That's just the very base, the code needed to actually instantiate an Angular application. And then we kind of like layer things on top of it there. You can create a platform factory for pretty much anything. And that's kind of what we're going to do here in a later step. So let's look at what providers are being provided here, right? Because you can see that first we have, what factory it's inheriting from, the name of it, and then each of them has their own like array of providers. So there's a lot here, but we'll kind of just like step through it a little bit. I kind of amalgamated them just so it's easier to follow. And we're not stepping through a bunch of different files, but we have like things like the platform ID, which is provided as a platform browser ID. We're not going to want to reuse that because we're doing web workers, not browsers. Platform initializers, the documents, right? So this is all the DOM related things. There is no DOM inside of the web workers. Web workers don't have access to the DOM. They're just their own like isolated JavaScript environments. The resource loader, that's specifically for pulling, like using URLs to pull resources. So again, we don't necessarily need that. Then we have our compiler options. So this might look a little weird, like why is the JIT compiler still provided when we're on full Ivy now? It's deprecated and it actually gets compiled out during your ng build as long as AOT is true. I'm sure Lars knows all about that, so he might be able to add some context after the fact. But we'll discuss why it needs to be provided in a little bit, but it doesn't actually get used if AOT is true, which it is by default now. And then our last little bits here. So these are the providers that are provided in the platform core, which is what we are going to inherit from. So we have our platform ref. That's what gets returned. That has that bootstrap module function. And then we have our testability registry, which we don't really need to worry about. And then console, which is just a wrapper around the console, essentially, right? You can provide over top of that if you really want to. I know some logging libraries might do that just so that they can like intercept different console logs and all that kind of stuff. So those are all of the things that are provided at that first main.ts level. So we need to create our own platform factory for web workers, right? There was the platform core dynamic, platform browser dynamic, all that kind of stuff, right? So the actual signature for the create platform factory is first we choose one to inherit from, or we don't at all, right? Because the platform core doesn't actually inherit from anything. It's the root level object that sets up everything. We're going to name our platform, provide any static providers that are provided right at app instantiation time. That's going to be empty if you really want it to be. And then return that platform ref. And that platform ref is what exposes that bootstrap module function that you pass the app module into. So what does this look like? So let's create just I don't know why the syntax title is all weird on this one, but whatever. We're going to create a platform web worker function here, or a factory, I should say. So we're going to inherit from platform core, and then add in a couple of other things like the compiler options, right? These are needed, even though they're compiled out. And the reason that we used platform core instead of platform core dynamic, which actually had those compiler options included in it, was because it's not actually exported from the Angular core library. Or I think that one's the Angular platform browser dynamic library, but it's not exported. So we just kind of recreated a little bit. But we inherit from platform core because it has that console, testability registry, platform ref providers. And then we name our name our factory, which we're calling web worker. Typically, you're using the platform ID and it would end up being, browser or server or something like that. But we're going to create one called web worker and overwrite that root one that was provided in the platform core. So now that we have our factory, theoretically we can bootstrap a Angular app inside of a web worker, right? I'm going to just skip over all the code generation stuff. There's going to be a repo. You can see how it's all done, but we just generate an Angular app with NX. I use NX for almost everything, and it makes all of the stuff way simpler. Generate a new library for your worker code, add a web worker, and then create a simple module. So right now we just have this simple worker module. This is what we're going to actually bootstrap with that platform web worker function, as you can see here. Don't need ng-zone. There's no monkey patching of DOM events or anything like that. So you just pass a nuke for that, since it's not completely unused anyway. So when you run it, what happens? Well, it sort of runs, but then we get some errors on it builds, and then we run it, and then we're like, oh, there's no error handler. Typically that's provided in, as you can see in the error, the browser module. Well, we're not importing the browser module because we're not in the browser. So let's take a look at what it is. This top code right here, taken directly from Angular core, all it really does is wraps a handle error function, just so you can implement some custom logic when an error happens. We're just going to create a little stub for it that logs it to the console. You're more than welcome to overwrite this. You can even overwrite it in normal Angular apps. This isn't specific to web workers. You can just provide your own error handler if you want. If you don't, it just uses the default one provided inside of the browser module. So we have our stub little error handler. Let's provide that into our platform web worker function. You provide error handler just like we normally would. Remember, these are all just static providers for Angular. Nothing's different, the fact that we're inside of a web worker versus inside of the browser. So when we run it again, well, now that one goes away, but we get another one, which is the application init status. So what is that and why do we need it? Well, the application init status, it has a lot of stuff in it, but essentially what it does is during application bootstrap, it'll run all of your different app initializer tokens. So if you're not sure what an app initializer token is, it's a little function that can provide it, and you can provide many of them, I believe, that run during the bootstrap process. And then once they all finish, then your application actually fully starts up. So because we didn't provide it before, when Angular went to bootstrap the module, they couldn't find the injection token, right? I'm sure we've all ran into the null injector error before. I run into it pretty much all the time because I forget to import reactive forms module or whatever it might be, right? So we don't need to recreate this. The application init status is usable by us. It's just not provided because we don't have the browser module. So let's provide it, use the same class because we don't need to overwrite anything, and then provide it to depths. Oh, and then we have this error again. Now there's nothing really done with it, so let's just add it, run it again, get the application ref. Error. Now we're missing one more thing. Errors just keep on coming. This was my first GIF of the presentation. I was very excited when I put it in. Another one. Okay, so what is an application ref? It's a reference to an Angular application running on a page. Well, we aren't running on a page, so we don't really need this. Let's just create a little stub for it and then provide it over the application ref injection token in our platform web worker function. Run it again. One more error. Okay, so it's saying that the simple worker module was bootstrapped, but it doesn't have ng bootstrap method, nor do any components have a bootstrap method. Well, we don't actually want to bootstrap the application onto the DOM, but we do need to satisfy the compiler because it is going to, or not the compiler, but satisfy the Angular framework because it is going to try and call this ng bootstrap function. So let's just say, here's a method, you can call it, no worries, just don't do anything because we don't really care. We don't need to load it into anything, right? All we're doing is instantiating the Angular service layer in the web worker. So once this method is called, we're kind of just good to go. Success. After we run it again, we now have it working. we now have Angular running inside of a web worker. You can provide whatever you want, it's functioning, but what are we going to do with it, right? Well, we can do almost anything that we want. Well, almost. So in the repo I'm going to share, there's actually an implementation with NGRX as well. You can import the store module, the effects module, NGRX entity, data, or any other Angular libraries, as long as there's no DOM access, into your app module in the web worker, right? And now you can have a web worker that runs effects that is running in a completely different thread than your main application. You can connect to WebSockets and make HTTP requests and all that kind of stuff. No DOM access though. Do not try and access the DOM because it will fail. Some of your libraries that you're using might access it without you knowing. So if you get errors around that, web workers are very strict in that respect, and they're actually prevented from doing that at the browser level. So now that we know how to bootstrap the application, how do we communicate between, one worker to another worker, or the main thread to one of the web workers? Well, there's two options. The first is post message. The second is broadcast channels. So note, broadcast channels are shared across all tabs based on that string, which is the web worker channel right here. So if you want to have a broadcast channel, but it's only shared within that one tab, the main thread and all of that tab's workers, then you would want to make some kind of unique key here that is created on tab creation, or like window open, and then pass that around. Otherwise, that broadcast channel is shared across your domain, across any number of contexts that are running under that domain inside of your browser. So, but broadcast channel is a nice way to say, okay, main thread, I want you to emit this value to all of the workers. Whereas with post message, you would need to post it to each one individually, right? So now that we can communicate, what can we do? What do we want to do? Well, we could wrap the broadcast channel in an NGRX component store. So, we create the broadcast channel, web worker channel, create an event stream. This is just a subject that's going to emit whenever there's a new event that comes through on the broadcast channel. Listen to the on message event of the broadcast channel. And then whenever a new event comes in, next the subject, and then do a thing. It doesn't matter really what you do, but now what we're doing is we're reacting to the events that are coming in. So each of our workers can be using this component store, and our main thread can be using this component store, and they all react to any time an event is pushed through your broadcast channel. So now you can start interacting between the workers and between the main thread. This pattern can be used everywhere. So you could write one service and reuse it across all of your workers and your main thread. And you can even subscribe to the event stream and pop that into an NGRX effect, or async that into one. Or I guess not async. There's no DOM access, but you could subscribe to it in any of your different services and stuff like that. So what's another thing we can do? Well, we can listen to actions across workers. So in the repo I'm going to share, there's actually a plugin for NGRX that sets everything up so that you can spin up, say, for web workers. They all have different stores with different effects initialized, and you can have a conversation with each other. So there's a little snippet in the center here. These are actually two different effects that are talking back and forth inside of different workers running inside one main Angular app. So what happens is an action's dispatched. That action is then transformed, sent along the broadcast channel. Then every other context, whether it be a worker or the main thread, receives that event, parses out the action, pushes it through its NGRX store, and then any other actions that result from that are then pushed back through the broadcast channel stream again. So you can see it. One says hi, and then one says hello there, and then we emit back, and then the other one says, how are you? And the first one says, I'm fine, thanks. So what we're doing here is we're actually pushing our broadcast channel events through our NGX store so that we can react to them like we do with any other normal NGX action. And then you can have actions that you don't want to dispatch through if you want. Subscribing to sources in a worker. So what if you have a source, an observable in a worker, and you want to subscribe to that from the main thread or another worker? Well, you can pretty easily create just like a simple pipeable RxJS pipe function to subscribe to the source, and then just anytime it emits, push that source payload through your event stream and then through the broadcast channel, which then all of your other contexts would receive, and then they can parse it out themselves. So this way you can set up different services like this timer. The example repo has this set up so that the main thread will console log, the interval every 1 second, but that interval is not running on the main thread. That interval is running within a web worker. So, not a very realistic. This is kind of a contrived case, but you can see how you could do iterative work in a background thread and then push that to the main thread. So there's some gotchas here because Angular wasn't ever really designed to run inside of a web worker, but we got it working. So I just want to make sure we understand this. If AOT is true for the application, that means that the web worker code must be precompiled as a separate step. This is because from my investigation that Angular will compile the app using AOT, thus removing the JIT compiler, but then it won't compile your web worker code using AOT. It'll just compile the code normally, but then you end up without the JIT compiler, and thus you can't start up your web worker. So NX is great for this. You can just create a separate library, a buildable library, generate your web worker code into it, compile that first, and then use NX's incremental compilation functionality to use that precompiled assets in your Angular bundle. Thus, you have a full Ivy compiled Angular app that is running inside of the web worker. Number two, the broadcast channel is slower than post message. I mean, slower, 12 kilobytes per millisecond, still a decent amount of data, especially if you're only sending some text data, but obviously the post message is quite a bit bigger. It's just post message that isn't shared across all of your different contexts, whereas broadcast channel is, and post message won't be shared at all across your different tabs where broadcast channel is as well. So broadcast channel kind of just simplifies everything quite a bit. And then any data inside of services in one worker is not available in another worker or the main thread beyond what is sent across the broadcast channel. So you can't like inject a service that is provided in one web worker into another web worker because they're different Angular apps entirely that are running in parallel, right? So those are just a couple of gotchas. If you want to check out the repo, here's the steps to clone it. You can run the serve build command that will run the incremental compilation and build server. It doesn't actually use ng-serve because ng-serve doesn't support the incremental compilation. So if you do that and you change the code because you want to like play around with some stuff, you will need to refresh your browser. Just be aware it doesn't refresh it automatically because we're not using ng-serve. We're using NX's, which uses HTTP server underneath, I believe. So yeah, hit me with the questions and your suggestions. I know that was a lot. I hope I explained it well because that was a lot of stuff.
That was awesome. Yeah, I didn't realize that there's some stuff going through on the chat there that sort of saying that they had actually deprecated the web workers in the end, but I hadn't realized they had. I'd completely forgotten that they deprecated them, but
they deprecated web workers?
I thought they had. That's what they're saying.
There was a web worker platform in Angular versions 2 to 10, and then it was removed. It did exactly what you just did, and then some.
Oh, well, there you go.
You said no DOM access, but the way to access a DOM is through the renderer 2 service.
Yeah.
And then the platform would delegate that to the main thread, in the main thread.
Gotcha. Yeah, I know. When I was doing my GD interviews with Steven, I believe, he was talking about how they were doing the web worker. They tried to run Angular inside of a web worker and they just couldn't get the speed. It wasn't performant enough because of the data sent back and forth. I just didn't know that it was actually like a public API.
That was no, it's very good. It's very good. It's amazing how when you start to sort of drill into how Angular sort of straps everything together to start with, and just sort of piecing that all together. I was just find fascinating.
Totally. Cool. Who's next?
At the moment, there's no questions.
I have a question. If
yeah.
Is it possible to load a specific part of the application in the web worker? And what I mean is that if you have, for example, a module, maybe a lazy loaded, that makes heavy calculations. For example, suppose that we have a module with a component, with a map component, and the map makes, some measurements and some drawings, and we want to make this type of interaction to the web worker, but the rest of the application could remain loaded in the main worker. Is this possible? Do you know?
Yeah, so you could definitely build something like that. The way you would want to do it is, so the component obviously needs to be part of, excuse me, the component needs to be part of the main app, obviously, because it's, it's interacting with the DOM. But inside of that component, you could spin up a web worker that has your Angular code running inside it, like specific, service type code in it, right? And then communicate back and forth with that using the communication channels that we talked about there, where you spin up a certain one with, maybe a certain broadcast channel kind of thing, and then subscribe to the sources using that ArcGIS pipe. And then you can async that data back into your template, and then let the Angular renderer take over from there.
Cool, thanks.
Yeah, no problem.
One question there from Thomas. What are some popular uses for web workers?
Yeah, so popular uses are usually for offloading, calculations that you don't want to stop the main thread. So like I was mentioning before, because JavaScript is single threaded, if you have a heavy computation running, your UI might stop being interactable, right? Like, maybe a spinner, if you have a spinner running, it'll just stop dead in its tracks. If there's some kind of animation or whatever, the browser won't be able to handle that. It'll just stop the UI so that it can go and do its calculation. Then when the calculation's done, it'll start the UI back up again, essentially, right? So if there's any kind of data processing that you want to get done, a classic test case is, well, I'm going to go spin off a function that calculates Fibonacci numbers up until the 10,000th number, right, in a web worker, and then return the time it took to calculate that, right? You don't want to calculate 10,000 Fibonacci numbers on your client, right? Or whatever number it would be to halt the browser, but any kind of offloading of data, right? Or asynchronous work, like if you have a, say a, high bandwidth WebSocket, right? But you don't care about every single event. Maybe you want to debounce the socket or whatever it might be. And then, every 1 second push a new value. You could push that into a web worker, and then the web worker is just like, then it's just emitting one thing every second back to the main thread, right? And then all that other, high bandwidth socket stuff is happening inside of a web worker, and it doesn't hold up your UI thread. And not just your UI thread, but that'll actually hold up any other processing you're doing inside of your app, right? It's not just the UI. It's all of your other effects and all of your other observables and all that kind of stuff. So anything that you don't want to hold up the user experience, you can push off into a web worker. So I see that Thomas then asked, like chats and notifications. Well, yeah, exactly. You could definitely do something like that if you really wanted to.
Oh, excellent. Okay.
I have not done any performance comparisons. This is kind of just like a proof of concept, just to see, if it was possible. I think the performance is going to be heavily dependent on the implementation of it and what you're trying to do inside of the web worker, for sure. Lars?
I did use a web worker to offload heavy computation at some point. I was tasked to do document processing in the browser. So the user would upload a very big CSV file, and I would have to process hundreds of thousands of rows, and that would block the UI if you did that in the main thread. So I offloaded it, and I even kind of used the what's it called, the divide and conquer, like upload it to several web workers and combine it in the end in the main thread. So they would upload a document, it would process it, convert it into a different format, and they could download it again right in the browser without any server interaction.
Yeah, and you can spin up any number of web workers. I'm sure there's some upper limit. I don't know what it is, but I doubt we would hit it. I can't imagine.
If you're processing hundreds of thousands or millions of records, then you might need a web worker.
Yeah, exactly. Yeah, or if you don't care about your UI or the performance of your application. But I mean, we do. We're web developers, so please care.
Hey, I'm curious.
Oh, sorry, go ahead.
Sorry, I'm curious. What's the browser support for web workers?
Everybody but Safari probably would be my guess. Does anybody know? Well, NIE obviously, but that's not an issue now.
Yeah.
I actually don't know it. I think it's, let's see, does MDM have does not have the compatibility table on this page.
Every browser but Opera Mini, all the way back to IE10.
Oh, there we go. Oh yeah, there it is.
It's old technology.
Mm-hmm.
Like we were using this 10 years ago in some browsers.
Yeah, but yeah, Safari doesn't support the on-message error event for some reason, but it supports all the other events.
Safari, yeah.
Yeah. I see a message from Chris in here. Can web worker communicate with, let's say, some API through HTTP? Yeah, so web workers have access to both the XML HTTP request as well as fetch. And I believe they have access to the socket layer as well. Excuse me. So they can communicate through any kind of APIs like that. So like I was saying before, you could connect to some chat socket in your web worker and then push updates to your main thread from there, rather than subscribing to that chat socket in your main thread. Or just call APIs or whatever, right?
Yeah.
Okay.
Yeah.
Maybe I did a better job explaining than I thought.
Yeah, no, that's really good. Really good. Okay.
Nuno says that Safari is the new IE6, but I don't know what is IE6. Does anyone know?
Doesn't matter anymore.
No. No. Okay. Just the one slide. So yeah, next up we have Aris talking about testing components with the Angular CDK. You're on mute, Aris.
This is my first time that I start speaking and I'm unmuted. Really? No, really. So hello everyone. Actually, my name is Aristeidis Bampakos, but as Duncan said, you can call me Aris because it is much shorter and easier to pronounce if you are not a native Greek. And today, I'm going to talk to you about how to test your Angular components with Angular CDK. The actual talk will be an introduction to a feature of Angular CDK, which is called component hardness. So, do you see my screen okay?
Yes.
Do you see the full screen? All right. So the agenda of today's talk is first we will see some of the basics of how we can unit test our Angular components. Then we will see what is component hardness and why should someone use it. And finally, we will see two examples of how we can use a component hardness either as the users, the consumers of a library with Angular material, or as the authors of a library, how to give to our users a better development experience in their unit tests. So some things about me. I live in Greece, in the second biggest island, which is called Evria, and I work as a web development team lead at a company called PlexEarth. I'm a group developer expert for the Angular framework, and also I work as a senior Angular tech instructor at CodeHub, where we train other developers and professionals to the basics and the secrets of the Angular framework. During the pandemic, I have written 2 books about Angular. The first one is called Learning Angular 3rd edition, and it is destined for beginners to the Angular framework. And the second one is called Angular Projects 2nd edition, and it showcases how to combine the Angular framework with modern web technologies. So each chapter is a different project that the reader develops with Angular and some other technology. For example, there is a chapter for Angular and NX, or a chapter for Angular and what's the other? And Service Worker. I hope that after Jay's talk, in my new book, I will write a chapter about Angular and Web Worker. So this month, also my Angular project book won 2 awards from the Book Authority organization. It was included in the best 8 new web application development books for 2022, and it was also included in the best 100 JavaScript books of all time. Now, at this point, I would like to say that both my books are published by Pact, which is the same publisher that the book of Lars is published. Lars has written a really good book about Ivy, so I would suggest you to go to Amazon or the PactPub website and take a bundle of all of our books to get a grasp understanding of the Angular internals. That's right. This is it. Sorry. Lars, I made a post just to promote your book. You know that. So if you want to learn more about me and connect with me via social networks, you can reach me at my Google developer profile, which is g.dev/Aristeidis. Unfortunately, Aris was taken, but I will find who took it and I will take it back. So let's get to the actual talk. When we say unit testing in Angular, usually we mean that we use the Angular CLI to run our unit tests, right? So the command that we use is ng-test. But what is actually happening under this command? First of all, our unit tests are files that have the extension spec.ts. So the Angular CLI collects all these files, compiles them, and passes them through a test runner like Karma or Jest. Now the runner will run the tests and it will output the result to a web browser, just like Google Chrome or some other browser. For example, if you are in the continuous integration environment, like GitHub Actions that Lars will talk about later, you can use Chrome headless. I believe so. And my preference for local development is also to use Chrome headless because I think that it is much faster than Google Chrome. So many things have been said and many things have been written on how to test your Angular components, but the proper way, and the Angular way actually, which is described also in the Angular official documentation, is to write our unit tests of our components so that they validate the interaction of our TypeScript class and the HTML template, always in the context of the Angular framework. And how can we do this proper way? Angular contains a class which is called testbed. It is a utility class that allows us to interact with our component in the DOM during the testing. So the testbed class actually creates our components in the DOM of the browser, just like the Angular framework does when we run the application, runtime. And then it starts inspecting how the TypeScript class and the HTML template of our component interact with each other. So let's see an example of this interaction with the testbed. Suppose that we are the authors of a library, of an Angular library, and inside our library, we have a component, the Hello World component. In the template of the component, we have a span element, and inside this span element, we have an ng-content element that allows us to project whatever content we want inside this span element as the consumers of this component. So if we would like to use this component from the library, after we have installed the library, of course, we would create, add in the template of our main component, the selector of the Hello World component, and maybe we could use Angular interpolation to interpolate the value of a name property inside the span element of the Hello World component. So if we run this code, we will expect that the value of the name property should be reflected into the span element of the Hello World component. And this is actually how we should think about component testing. Our first unit test would be to validate if we set the value of the name property, that it should be represented correctly in the span element of the Hello World component. So we're actually talking about integration component testing. You may have heard this, term. So let's see how we would write our unit test. Okay, first we need to set up our test suite. So we have the usual import statements. The first import statement, we import the testbed class that we want to use and the component fixture. The component fixture is actually a wrapper over our component, and it provides us access to the actual HTML element during testing. Then we import the two components that we will need for testing, the app component and the Hello World component. So in our before each statement, first we use the configure testing module method of the testbed class to configure a testing module for the test. This is a module that is used only for testing. Just like, let's suppose that we can think of it as a temporary module. And in the declarations of this module, we add the two components, the app component and the Hello World component. Then we use the create component method again of the testbed class to create the fixture of our component. And we pass the app component as a parameter because this is the component that we want to test. Finally, we can get access, we can have access to the TypeScript, to the actual TypeScript instance of our component using the component instance property of the fixture. So far, so good. Let's start to write our tests. Now, the first test that you see here is automatically created from the Angular CLI when you generate the component with a unit test file. So I personally like this approach because this component actually checks that you have set up your testing module correctly for the component testing. It actually checks if it can be rendered and initialized correctly during testing. And the second test is the test that we're going to write. So first we set the name, we set the value of the name property. Then we call the detect changes method on the fixture to trigger the change detection mechanism of Angular framework. And then we can use the native element property of the fixture to get access to the actual HTML element object of our component. And from there, we can use standard HTML methods like query selector all to query specific HTML elements that exist in the template of our component. For example, in this case, we are looking for the span element. After we find the span element, we can access the text content property and check if it is the same with the value of the name property. Right. So, suppose for some reason that the author of the Hello World component of the library wants to replace the span element with the paragraph element. What's going to happen if we run our tests? They will fail, but they shouldn't fail because our unit tests should not care about the actual implementation of the component of the library. They should only care about our component, right? So what can the author of the library do to make our lives easier? They can start using the Angular CDK. It contains a feature which is called component hardness, and it allows us to write our unit tests so that they do not rely on the internal component implementation. They do not touch the DOM directly, but act as a wrapper over the DOM. Actually, they are a wrapper over the fixture, and the fixture touches the DOM. So the component hardness is a collection of classes that we can use to configure our unit tests so that they interact with our components using a public API. The pattern that the Angular CDK uses for component hardness is heavily inspired from the page object pattern that some of you have met in integration testing libraries, for example, Protractor or Cypress. So what are the actual main parts of a component hardness test? First, we need an NPM package, which is the Angular CDK testing NPM package. It is a package that contains all these infrastructure and artifacts for interact with a component hardness. Second, we need a testing environment that we can use to run our tests. Angular CDK provides us with two testing environments out of the box. One for unit testing using Karma, and one for end-to-end testing using Protractor. Then we need a hardness loader, which is a class that is used to load a component hardness inside the test. And finally, we need the actual component hardness, which is the class that gives us access to the instance of our component in the DOM during testing. So let's see some examples of how we can use component hardness. We will start by checking an example. We will pretend actually that we are the users of the Angular material library, and we want to test our components that contain some Angular components on their template. So let's get started. Suppose that our application contains a button component, and on the template, we have an HTML button element. And this button also contains, it is rendered as an Angular material button, as you can see from the mat button directive. And the text of this button is interpolated using a title component property. So if we would like to test this component, we could follow a similar approach to the one that we saw on the beginning, where we set up our fixtures, and the fixture then starts querying our DOM. So for example, we could query our DOM for the button, for the HTML button element. It can be done like this, but the purpose of this talk is to showcase the component hardness. So we will go in another way. We will try to query the Angular material button and get the text from there, not from the HTML button element. So how we would set up our test suite? the setup is much bigger. There is a lot of boilerplate code when we work with component harness, except of the standard imports that we have on the top that we had before also, the component fixture, the test bed, and the button component. We have 3 additional imports. The first one is the harness loader class that we need. The second one is the testing environment, which is the test bed harness environment. It is the testing environment for unit testing. And finally, we have a mat button harness class. What exactly is this mat button harness? And if we, each Angular material component has a component harness implementation. For example, the mat button has a mat button harness. If in your application you use a mat checkbox, there will be a mat checkbox harness class. So the Angular material library contains an implementation of component harness for roughly most of their components. So in the before each statement, after we configure our testing module and we create our component, we use the loader method of the testing environment to actually create our loader. And as you can see, the loader takes the fixture as a parameter. Why? Because the loader is tied to a specific component fixture. And that is why we say that we have the DOM, and on top of that, we'll have the fixture, and on top of the fixture, we have the component harness. It's one more layer on top of the fixture, of the component fixture. So how we would write our unit test? First, we set the value of the title property, and then we use the loader to call the getHarness method, and we pass the specific component harness implementation as a parameter, which is the mat button harness. So this line, the getHarness, calling the getHarness method will actually gives us a reference to the actual Angular material button that we have on the template. Then we can use some methods that are supported by a component harness, like getText, that returns the text of the button, and we can validate it with the value of the title property. Now, in this approach, you need to pay attention to 2 things. We use async await syntax because everything in component harnesses is promise-based. So it is much easier to read. And the second one, very, very important, is that we don't need to call the detect changes method on the fixture because change detection is automatically triggered in component harness. Let's say that we had 2 Angular material buttons and we wanted to target only one of them in a specific unit test. In that case, we could use a predicate function, as it's called. And this predicate function, we can pass the text of the specific button that we want to target. For example, as you can see, the getHarness method now doesn't take a single mat button harness class as a parameter. It actually calls the with method of the mat button harness and passes the text of the button that we are interested as a parameter. So the second test will target the button that contains the click me text inside it. That's great so far. We have already seen how to use a component harness as users. Personally, I use Angular material a lot in the company that I work, and we use component harness all day long. Now, let's see the other flip of the coin, how to use the component harness if you are the author of the library. Do you remember on the beginning that you were the author of the Hello World component? And we had the problem of replacing the span element with a paragraph. We will solve this issue. And we will solve it by creating our component harness for our component. Sorry, we will create a component harness for our Hello World component. And how we can do that? A component harness implementation is nothing more than a TypeScript class that extends from the base component harness. And it contains at least a host selector property, which is a static property that identifies the underlying component and usually is matched with the selector. So in this case, the host selector and the selector of the component are the same, app hello world. Additional to that, we use a locator for method to actually read the span element from the DOM. The locator form method is doing the same, roughly the same job as the query selector did from the picture that we saw in the beginning. So the locator for will return a test element object that contains common methods that we can use to interact with the DOM. For example, click, focus, text that we use here. We use the text here to get the text of the actual span element. So we have created a getText wrapper method similar to the getText method that the Angular material has. And we call the locator for method to get the span element, and then we return the text of the span using the text method. Right, so we as authors wrote the component harness, we released a new version, possibly with Github Actions. We will see that after with Lars. And we have deployed the new version to NPM. Now our users can download the new version and start using the component harness in their tests. How? Let's see. Now, this unit test is the same as the one that I showed you in the beginning with the fixture. I have omitted the initial setup for simplicity. So in this version of the test, we set the value of the name property. We call the getHarness method of the loader, and we pass the specific component harness implementation for the Hello World component. And then we can call the getText method that we created to validate if it is the same with the value of the name property. Awesome. Now, what will happen if the author wants to replace the span element with a paragraph? They can go back to their component harness. They will change the locator for method to target the paragraph element. They will deploy the new version. They will release and deploy the new version to the NPM. And we, as the users of the library, we will download the new version, and we don't need to change anything at all because our unit test will still running. Why? Because we don't rely on the internal implementation of the Hello World component anymore. So, problem solved. So, to recap what we have seen in this talk, first, I would suggest you to go and write your unit tests with the Angular CDK, even if you are using Angular material or some other library that supports it, or if you are the author of the library. We saw how to properly test an Angular component using the Angular way, the official Angular way. What is a component harness and how we can use it? And we also saw two use cases, either if we are the users of a library, of Angular material, for example, and then if we are the authors of a library, how we can provide added value to our users through our libraries. In this link, in this slide, I have put some useful links about testing and component harness. The first one is a stack blitz demo that I have created, which contain all the sample code that I showed you tonight. Of course, it contains more examples. For example, you will find an example, an implementation of the predicate function that we saw of the Angular material, how to write your own with method. And all the other links are from the Angular material docs and Angular docs. So that was it. Thanks very much for attending my talk. And I would be very happy to answer any questions that you have.
Thank you very much, Aris. That was really interesting, actually, because I've always wanted to be start to use the Angular CDK for testing and stuff, and that was a really good insight to it. Actually, thank you.
Thanks a lot. Actually, I have seen that you post regularly about Angular CDK, so
Yeah,
it would be a good fit to test it.
Yeah, it's on my to-do list to get to the Angular CDK, but yeah, bits and pieces with Angular material and Angular Flex layout is my other favorite one I use.
Yeah, I use it also in one of my
right.
POCs. Yeah,
I do like that. Can you use Angular CDK then with other frameworks, or does it have to be with Angular material?
no, you can use it. Angular CDK is actually the skeleton of the Angular material. This is how Angular material was created, was built. So
right, okay.
I know many examples that they use Angular CDK without Angular material. Lars, well, Lars has a question. I hope.
I was going to say,
yeah, another point worth mentioning about these component harnesses is that they work in unit tests or component tests, but they also work in end-to-end tests using the same component harness. And that's really powerful as well.
Oh, right.
Yeah, that's very correct, Lars. Thanks for pointing out. But I think that they have only a testing environment for Protractor, but now that Protractor, it's not fully supported. I don't know if there is implementation for other. Do you know if there is an implementation for other?
Yeah, Eunice created one for Cypress.
Oh, cool.
And it's supposed to be simple to create one yourself, but it was really like Eunice has criticized it for being very protractor specific, the interface for creating a test harness environment.
Yeah.
But he managed to create one anyways for Cypress. And you're right, there's only one official one that's for protractor, and now that's deprecated or gone, you need to look for something else. But a lot of people use Cypress. So if you are using Cypress, you can use the CDK or the component harnesses for the material components in your Cypress tests, rather than using the Cypress selectors and matchers.
Okay.
I had one person in another talk actually made a very good point that if a library doesn't have any component harness and you are the user of the library, you can write your own component harnesses that target their internal implementation. So you could reach a point where you maintain the component harnesses of another library.
Yeah, that's right. By the way, a big reason for the component harnesses, a big reason that they're there is that if you use Angular material components in your app and you have tests that kind of rely on their selectors and whatnot, you're going to be very sorry as soon as the Angular material rewrite to MDC components lands sometime, maybe this year or next year at the latest, I would guess. Because then some of your test will start breaking. But if you're using component harnesses to kind of select those or interact with the Angular material components in your tests, then your test will keep working after the internal rewrite.
That's worth knowing, actually. That's handy. That's because
there's a question in the chat, right?
Yes, I was just going to say there's a question in the chat there from Thomas, and I've just lost it now. Where's it gone?
Duncan, can I post the slides deck in the chat?
Yeah, if you want. Yeah.
Okay.
Yeah,
cool.
Yeah, more than happy. Thomas, when do you, as the question is, when do you decide to mock your subcomponents, and when to use the the test component integration with Hardness?
Actually, I would mock the subcomponents only for when I test their parents.
Right.
All right. And yeah, actually, if you mock the subcomponents or use the original implementation, I think they're not related. Or am I missing something in this question?
So if you have an Angular material button as a child component to your component and you want to test that your component, when do you make a shallow component test for your component? When do you use the Hardness for the map button or whatever?
Yeah, I always go for the component Hardness if the library supports it. But if I can test the component with the fixture, for example, like the example that I showed, I had a button HTML element and an Angular material button. In this case, I can go directly for the HTML button element, so I don't need to load the component Hardness. But if there is another way, yeah, I will go for the component Hardness. For example, I use the component Hardness especially in the Angular material tables, which are more difficult to test.
So up next, we have Lars talking about GitHub Actions and Workflow Abstract. Over to you, Lars.
Yeah. Abstract is not really part of the title.
Oh, sorry.
So no, there's nothing abstract about workflows and actions.
Sorry, that was my.
There was an abstract after that part of the text.
Yeah, sorry.
Description of this presentation. So that's the misunderstanding
picked the wrong thing up.
Well, thank you for having me, Duncan. Last time I was supposed to be here, as I had to ask very nicely Santosh to come fill in for me because I had a bad case of COVID. But now I'm happy to be back. Thank you for inviting me, Duncan. And Jay.
Nice to finally meet you, actually.
Yeah. No, oh, yeah. The first time I was speaking here was someone else being the host then.
I think it was Michael.
Yeah. Right. So yeah, thank you very much for having me, Duncan. I finally succeeded. Aristeidis, Jay, thank you for your talks. They were great. And I'm very excited to be here with the community. I'm actually interested, where are all you people from? Like, this is Europe and Africa. Do we have anyone from Africa here? And the rest of you, where are you from? I think I saw someone that might be from Ukraine as well. Alexander
Poland, Belgium, India, Argentina,
South Africa.
We're all over the place. Holy.
Wow. Argentina,
Netherlands,
Germany as well. Nice.
Am I the only Canadian? Are there any other Canadians here?
Very, very, very international.
Another one from Greece.
Yeah, this is part of my team at work. Yanis.
Oh, support. Yeah.
Thanks, Yanis, for the support.
Okay, well, nice to see such a big crowd from all over the world.
Yeah.
So yes, let's see if I can figure out. I don't use Zoom much, but let's see. Trying to find the right button. So yeah,
there we go.
Should be good now, right?
Yep.
And today we're going to be talking about GitHub Actions and Workflows. This is an introduction to this kind of CI system on github.com. And we'll end with a demo of an Angular application with GitHub Workflow and look into a few pieces of code in detail. So the first part here is going to be an introduction to the different parts of GitHub Actions and Workflows. So make sure to prepare your questions, and hopefully we can have some time in the end to answer them or look more in detail at that workflow. The demo will also be publicly available in a GitHub repo. You can explore yourself. So the name, first of all, the name of GitHub Actions is pretty bad, because on github.com, there's a tab that says actions, but what's listed there is action, not actions, it's workflows. And workflows use actions, but they are not actions. But actions is also the umbrella term for workflows and actions. But I like to separate them out and speak about workflows and the actual actions that are kind of the reusable steps that can be used across different workflows. So you might be used to having a CI or CD provider of some sort. And this is one of the things you can do, absolutely, you can do with GitHub Workflows. But GitHub Workflows is much more than that. It's actually an event-based system. And you can, yeah, sure, one thing you can use an event to trigger a CI/CD workflow is a push to a branch or a commit to a pull request, or even a manual run of that workflow, which is called the workflow dispatch event in GitHub terminology. But there's tons of other events in the GitHub platform itself. Say you can trigger it using a webhook. So you can send a web request from any system to trigger a GitHub workflow. So you can imagine the possibilities from that. You can trigger a workflow based on the commit to a pull request, a commit to any branch, a tag on a commit can trigger a workflow, a GitHub release can trigger a workflow, or even a comment in an issue or a pull request or anything like that can also trigger a workflow. So you can automate all kinds of things. So the other part of actions is the actual actions. And these are the reusable logical pieces of tasks you want to run in your workflows. There are some that are kind of semi-official because they're created by GitHub. So you usually use a few of those, like the checkout action to check out the source code of your repository into a job in your workflow. But there's also, I think, more than 100,000 third-party actions on the GitHub marketplace, and you can create one yourself with relatively low effort. I'll give you kind of an introduction today on the different ways we can create an action and use it locally, or have it in public and have it on the GitHub marketplace. And that's the third point here about the custom actions that we can create ourselves, even if it's for the benefit of just our own workflows. So first, we're going to look into the workflows here. And these are the sets of jobs and tasks we want to trigger from some events. Here's a kind of a small example of that. So we have a workflow. It's called the CI workflow. It has triggers on commits to pull requests and push commits that are pushed to the main branch. There's a job. It's called build. It runs on an Ubuntu server inside of the GitHub Actions runners that are actually hosted on Azure, because Microsoft owns GitHub. And this job has a few steps. So there's a checkout step to get the source code from your GitHub repo into this GitHub runner, and then we install Node.js, and finally we call the build command. So that's a full but small single job workflow here that you might see in some CI setups. So the structure of this is each workflow has a name, has one or more triggers. It can have environment variables that are shared between your jobs, and it has one or more jobs, like the one we just saw. There are these built-in triggers. We discussed a few, but there's also a kind of cron timer from Linux. It's called a schedule event. There's this manual event where you click the button inside of github.com to trigger a workflow, and you can pass it input parameters as well. It's called the workflow dispatch. There's this webhook that's called the repository dispatch, and the push event, pull request event, and an issue, or even if someone creates a fork, you can run a workflow as well. And a few others here. Even when someone does something on the GitHub wiki, you can trigger a workflow. So like it's endless possibilities here. There's also a third-party package here called Actions Flows, and that takes it to the next level because it adds custom triggers besides the one provided by GitHub. So we can pull an API to determine a RESTful API, for example, to determine when we should trigger a workflow, or we can respond to an email being received. We can respond to an entering Google Forms, poll a GraphQL API. We can have any JavaScript to determine when to trigger a flow. We can trigger a flow based on an NPM package release, an RSS feed, the weather changing, Instagram post can trigger a workflow. Like this is some next level stuff here. There's a bunch of more here. So yeah, anything you can imagine almost you can automate with a GitHub workflow. That's pretty interesting. So Actions flow is actually free if you use it directly in GitHub, but if you do like limit the schedule, you shouldn't be polling this every minute, for example, if you're using the free version of GitHub, because then you're taking up compute from everyone else, and GitHub won't like it. But you can also host your own action flow server, and then you're free to do whatever you want. Then you're using your own compute. So use it sparingly if you're using the free version, and you should look into using a self-hosted versions of Actions Flow for the server part. GitHub workflows, once we have this trigger and the name defined, we're going to declare some jobs, and we can have one or more jobs per workflow. It has a server image, so it'll either be an Ubuntu server, the different versions of it, a Windows server, or even Mac OS server. And we can even give, say, a Docker file to run in a custom OCI container image inside of a job. We can specify environment variables that are specific to a job, besides the ones that can be shared between jobs. We can have environment variables for a single job. A job will have one or more steps that perform certain tasks or actions. A job can even have dependencies on other jobs, so you want to make sure that build runs before the end-to-end tests that test that build in a web server, for example, or you want to build before a deployment. A job can even have output values that can be used in other jobs that will depend on that job. So a computation or something from one job can be used in another job that depends on it. That's a bit of advance, but it's a possibility. So here we have a job like before. It's a build job running on Ubuntu. The first step is the action/checkout. And if you go to github.com/actions/checkout, you'll find the source code for this GitHub action. It points to a GitHub repository, and then comes the @ and it says v2. That's a tag on this repository. So inside of this repository, you'll find an action.yml, a YAML file, defining what this action does. So every time you see an action, you can look up the source code on GitHub by writing github.com/before the action name. That's pretty powerful as well. It's like in the old days when we would go look at source code for websites. Today they're minified and uglified and whatnot, but back in the day, that's how we learned. Same for actions. You can learn from other people's actions, and especially the ones by GitHub. So every step in a workflow can be, for example, an action. So it's using an action to perform that step. It can be a local action or remote one, like the actions/checkout action from GitHub. We can refer to a version, a tag, a specific branch, like the main branch, or even a specific commit, because it points to this GitHub repository, and we can refer to any commit on that repository, or any branch, or any tag, or any version. So an action can optionally have input parameters, and it can also output result values, but it doesn't have to. And it can have a name as well when you're defining the step. So this is looking at the perspective of a step in your workflow job. You'll give that step a name. It'll use an action, and you can pass inputs to the action, and you can refer to the outputs of the action. We'll see examples of that. So here is another action step. We can see that because it has the uses parameter here, and it's pointing to the actions setup node. So that will install Node.js version 16, and it will cache the dependencies using yarn. And yeah, I probably forgot a yarn install step here. It doesn't run yarn install. It just caches the yarn cache folder. But so there should have been a yarn install here. But after that, we can go to the next step, which is yarn build. But this is an example of having an action step in your workflow job. Besides the action steps, we can also have a run step. That's a terminal command using a shell. If you don't specify a shell, it will be dependent on the operating system. So we were using Ubuntu, so by default that would be the bash shell, but it also has the PowerShell core shell available. And if it was a Windows server, it would have both the PowerShell and the PowerShell core commands, and Mac OS would have the bash. Anyways, if we don't specify one, we'll get one depending on the OS. So for a run step, we can also specify a working directory for that terminal command, and then the command itself, of course, and we can name it. And the reason for naming a step, be it a run step or an action step, is it'll be visible when you see the workflow running on github.com. We'll see examples of that in the demo. So this is the run step. We're calling a yarn command, but it could be any terminal command. And since this is Ubuntu, it'll run in the bash shell. So any bash commands will be available to us here. We can also have conditions in workflows. There can be a condition on a job. For example, only run this job if this is a pull request. We can have conditions on a step. So that could be only run this deploy command if it's a push to the main branch. Here's an example of that. So our lint command, we only want to run it on a pull request. So we put the if with a conditional statement here on the job rather than on a step. So this entire job will be skipped if this is a push to the main branch, for example. Another part, more recently, like half a year ago, we got reusable workflows. So we can take steps in a job and we can make them reusable so that we can kind of reuse them between jobs and between workflows in our repository. If we put it in a special .github repository, we can even, in our organization on GitHub, we can even reuse it across repositories as well. So yeah, just be aware that we can chunk them into a reusable workflow and add input parameters, pass it secrets, and even have some output parameters as well. This is what it looks like when we're calling a reusable workflow. So I'm referring to it in this repository. It uses my deploy reusable workflow. It passes a username as a parameter, and it passes my token secret to this reusable workflow. So that was everything about GitHub workflows. Now let's get into the actual GitHub actions. And I don't mean the workflows, but the actions. So what can you do with an action? You could publish a package to NPM. You could deploy a package to a server. You could send an HTTP request. You could install dependencies in a job. You could run any kind of tool if you had the right setup on the GitHub agent. You can manage your cloud environment. You can comment in a pull request. Remember all the different events. Like you can trigger a workflow when someone comments in a pull request, and you can kind of make a bot that replies to them using a workflow. You could send an email. You could create and send a report to someone. You could send a chat message in Slack or Discord or Teams or whatever you're using. You could do this from a workflow, an action in a workflow on GitHub. So an actions has a few configuration parameters. It has a name. It can have a description. It can take input parameters, and it can also declare output result values. You have a few different options when you're creating an action. It has to have a type and an environment. So there are a few types. The first one is the Docker container action. So we can run an action inside of a Docker container. So if we specify a Docker file, and that means we can write a GitHub action in any programming language if we wrap it in a container. There's a special way to interact with the input parameters. They are passed through environment variables. And when you want to set the output parameters, you do that using a special terminal command that you echo at a certain command. But other than that, you can use any programming language. But the second type is JavaScript actions, because GitHub Actions have first-class support for Node.js. It supports Node.js versions 12 and 16. And the final type is the Composite Actions. They are a bit special. Let's look at the first one in a bit more detail here. One thing to note is that they only support the Linux containers, so you can't write a GitHub action in a Windows container. The benefit is that you have an entire environment that's included with the action, so it doesn't depend on the GitHub runner that runs the workflow, because a container image is instantiated that brings the entire environment that you need for your action to run. But it doesn't have access to the file system directly. So that's kind of a downside. It's easy to test locally because it's inside of a container. And so we have tools for that on our own machine. It's a bit slower than the other action types because it has to spin up a new container, which is actually inside of another container probably. So it's a bit slower than the other types of actions. The input values here are accessible through these special environment variables. And we have these special terminal commands for setting output values using our container action. This is what it looks like. It has the name and a description, input parameter, output parameter, and then the final part is the important bit. So we're saying using Docker, and then we're specifying a path to the Docker file. And then GitHub kind of does the rest of the work for us. It spins up the Docker file and maps these inputs and expects some output to be created by the container itself. Here's just some random container. It's running on Linux Alpine. It has a shell command that it's running, and that's it. And the shell script is accessing this input from an environment variable, and then it's taking the current date and adding that as an output value. So it looks like this, but we could use any programming language here. We could install all the packages we wanted to use in our favorite programming language because we're inside of a Docker container, right? So that's maximum flexibility. But if you're creating another one of the other types, then you have a few more benefits. So since we're Angular developers, we might also know Node.js. And when we use Node.js, we have some NPM packages available. We have access to the file system of the job in the workflow. We can also test it locally by setting environment variables using this pattern here. We have direct access to input and output values using some NPM packages by GitHub Actions. It's faster to spin up than the Docker container actions because it runs directly in the workflow, the GitHub runner running in the job in the workflow. it's also faster than having a composite run step action that calls a Node.js scripts. So it's a good option if you know Node.js and has support for version 12 and for 16. We have access to all these pre-installed npm packages that are all related to running a GitHub action. So we can manage build artifacts and cache dependencies and access the input and output values and all of these good things, even down to having a GitHub client. So we can interact with all the things you have in a GitHub repos, like pull requests and commits and tags and releases and things like that. So this configuration is very similar to the one we saw before, but in the end we have using node 16, and then we pointed to an MJS file for what's it called? ES module, right? So that's supported in node 16, which is pretty sweet. Composite actions are when you create an action that reuses steps, but only run steps, not, no, actually, it can also be action steps. So if you don't want to write any custom code, you just want to, we want to reuse some existing actions and pass a specific set of parameters to them, reuse that between our jobs, reuse that between our workflows, then we can create a composite action. And when we do this, we can use any terminal script or programs that we have available inside of the GitHub runner. So that is also quite flexible and without the overhead of having to create a Docker container and install dependencies and all of that. So this is what that looks like. In the final section, we see using composite, and then we have the steps directly in the YAML configuration file for this GitHub action. So this is just some random number generator, right? So it outputs something, it has an output parameter, and then it says goodbye. Important note here is that we have to specify the shell. Otherwise it won't work. So we have to explicitly set a shell for the run stuff. So here I'm specifying bash. Yeah, and this is what inputs and outputs look like when using the composite action. And here is an example of a composite action that reuses other action steps. For example, some Docker logic here for publishing to the Docker registry. Right. So now down to the demo. I think that's the final part. I have to figure out where it is. This what's it called? The Zoom thingy is getting in the way. I'm really bad at Zoom.
Yeah, no, that's a real pain when you're trying to get access to something and then Zoom puts the menu down at the top there. So.
Okay, here we are. Zooming in a bit, and where did this chat go? Here it is. I'm posting the link. Hopefully you can find that. So that's a public GitHub repository. Here I created an Angular CLI application and added a few components and things. If we go into the workflow here, I created, oh, by the way, so we place it in a special folder called .github and then /workflows. And any YAML file inside of here, it cannot be in subfolders, but any YAML file here is assumed to be a GitHub workflow. So if we follow all this configuration we just learned about, then it will be active. So for example, this one, I hope the font size is all right, by the way, or let me know.
Yeah, it's fine.
Good. Might zoom in a bit more actually. So here, this is the continuous deployment workflow. It has a few environment variables here. Oh, I should actually go to this branch I created instead. Here it is. Yeah. So it has a few environment variables that I'll use somewhere in my jobs of this workflow. And here are the triggers. So on a push, so a commit that's pushed to the main branch, this workflow will be triggered. But also when there's a commit to any pull request in this repository, this workflow will be triggered. And this event, the workflow dispatch, is when I manually click in github.com up here in the Actions tab. I can manually trigger this workflow as well on a branch. Then comes our jobs. So we have a lint job, we have a build job, we have a test job for unit test, we have a deploy job here as well. And then a special thingy here for Sonar Cloud that we might look into. So what does this job do here? We all know the ng-lint, right? So I wrap that in a yarn script, because it doesn't matter whether it's Angular CLI or any other CLI being run behind the scenes, since we can create any, or we can run any terminal command here in our job. But this is kind of typical here, that we check out the code. We set up a node version, and here I configured it to read the node version from this NVM configuration file. It's caching the yarn dependencies so that it speeds up the installation progress. They're kind of cached in the GitHub storage rather than having to download all the yarn packages from npm every time we run it. Instead it's restored from a cloud storage. So that they made that pretty easy here with this setup node action, that we can specify yarn or npm or pnpm here to cache our dependencies. Then I run yarn install, and then I run yarn lint in this job. The other special thing about this job is that we have this condition. So linting is only being run in a pull request. We have access to this GitHub context object as part of our workflows, and we can look at the event name, which whenever that is pull request, then this job is being run, and if it's not a pull request, it will be skipped. The other jobs are kind of similar. There's a build job. Here I'm using the PowerShell core terminal just for fun, and similar thing, we check out and set up Node.js, install yarn, and then we run yarn build, which is probably just ng build behind this npm script here. And now down here we see a special thing. We're using actions upload artifact. So we're actually uploading this folder dist and then the name of the Angular app here. We're uploading that and we're calling it by the bundle name. This is an environment variable that we set at the beginning of this workflow. So all the way up in the top, there is an environment variable here called bundle name, and the value is Angular app. So going back here to the build job, we will upload a build artifact to GitHub that's called Angular app, and it will zip this folder and put it inside that build artifact. If there are no files in this directory, an error will be triggered, but otherwise this will succeed. This job, the test job, as you might imagine, is probably something like ng-test behind the scenes. And finally, we have a deploy job. This one is special because it has a few conditions. It's only being triggered on a push to the main branch, and it depends on the build job to finish first. So the first step here is, rather than checking out source code, we are actually downloading this build artifact using this name, Angular app, and then another environment variable that we have defined only for this job right here, called the bundle path. So we're unzipping it to a folder called Angular app. And then finally, we are deploying it to an Azure app service. So this is kind of a typical Angular application CI/CD workflow on GitHub Actions, which is actually a GitHub workflow. And then finally, I have some magic here with Sonar Cloud, which is free for open source. let's look at what this looks like in the pull request when this workflow is being run. So I created a pull request to add a dashboard feature. It doesn't matter what's in it. What's interesting is down here, first we see this Sonar Cloud bot. This is something that's called a GitHub app. So it can interact with our pull request. We uploaded some lint reports and test reports to Sonar Cloud as part of the workflow. And it reports back that there's 100% test coverage, 0 duplication, 0 bugs. It scans for possible bugs, vulnerabilities, and security exploits. But there's actually 2 code smells, so I might look into that. Other than that, we can see our different jobs here, down here. We saw the Sonar Cloud app is being run successfully. Other than that, the other here are jobs in my CD workflow, the file we were just looking at. So we see the lint job, it went well. There's a check mark here, 35 seconds, that's pretty fast. The build job triggered by a pull request was also successful in 1 minute. Unit test failed. The Sonar Cloud scan job was successful, and the deployment was skipped because of the condition. We're not supposed to run it on a pull request, only on the merge domain. So let's look into the details here. Then we can see that what happened in this job. The steps here, like running the checkout and then running the setup node command here, installing the dependencies, and finally running our tests. And what happened in our test, it was running Karma, and then there was an actual error here. And since I uploaded, like one test failed, right? But since I uploaded it to Sonar Cloud, if I go back here, I can go to the, oh, right. So Sonar Cloud is reporting coverage, test coverage only in this case. You can add another report called the test execution report, so that Sonar Cloud knows how many tests failed and succeeded. But to do that, you have to turn it into a special XML format, and I just didn't put in the effort to do that yet. So currently, I'll have to look at this output right here in the job to see which test failed. So it's the one called dashboard service should be created because of this error right here, an expectation that failed. Another nice thing we can see here is now I'm in one of my jobs, but if I click the summary for this workflow, I can see it visually, how they are related. So these 3 are being run independently. One of them failed. The build job completed in 1 minute, 12 seconds, and then the deploy job would have run, except it's skipped in this pull request, right? It's a pull request trigger. If it was a push to main, it would also have been called. So this is a nice visualization of my jobs in this workflow, and I can click either one of them to see the output of running that job. So this one went well. We can see the lint report here, ng-lint. All files pass linting in 4.15 seconds, and installing all my npm dependencies. It was with Yarn, but that was done in 21 seconds because of the caching. So GitHub Actions and workflows are pretty darn fast. They are free for public repositories. You have up to 30 GitHub runners for free in a public repository. And they're relatively fast with 2 vCPUs, fast enough for most needs at least. So that's a really awesome feature of GitHub, and it allows you to check out all these awesome features, try them out. And GitHub is where open source is at. So you can learn a lot about how to create your own or how to understand other people's workflows on open source projects as well. And that's everything I had for today.
Oh. Thank you very much, Lars. Yeah, I have touched upon GitHub Actions. I've sort of added it to my profile page in GitHub, where you can, I think I've linked it to blog posts and YouTube videos There's some action there. So, and I think I set it to run every Monday, to then go and check it. So yeah, it's pretty powerful stuff. It's very
Actually, I have a
very
question.
similar to. Sorry, go on.
Aristeidis? Yeah.
Yeah. Actually, I have a question. I was thinking a lot about integrating into our team the GitHub Actions, but what's your opinion about small teams where each developer works in a different project? For example, now we run linked tests locally on our machines because we're a very small team, right? Do you think there is a benefit of moving this into the GitHub Actions and not doing it locally for small teams?
Always. It's the first thing I do when I join a team. If it's not already there, I'll set up a CI workflow, at least a basic one. You really need those CI checks to be automated, to build the lints, the tests, so that there's no room for human errors. You should also make sure you do pull requests for every single change, have it reviewed, have it go through CI checks.
Right.
Even on my own solo projects, I'll set up CI workflow as the first thing.
Really? Okay. I have never thought to do it like this. Yeah, the human error is a factor, is a real factor. Yeah, I mean, even for small teams. Recently, we moved to Azure DevOps, and I would like also your opinion between GitHub Actions and Azure pipelines. What do you think?
I have used Azure pipelines a lot as well, but I'm very happy to be using GitHub Workflows in my daily work as well now. Also, yeah, I'm a GitHub star. I'm a Microsoft MVP, so I do have access to the product teams both at Microsoft and at GitHub and at Azure DevOps. So, I need to reassure you that Azure DevOps is not going away. But that being said, new things will happen on GitHub. Azure DevOps will keep being available, but it will have very similar features to what it has today. So if you're happy with Azure DevOps, by all means, keep being on Azure DevOps. It's not going away, like not until Jay is dead or something. I don't know. And but if you have feature envy, you should migrate to GitHub Actions because that's where things are happening. But if you have an existing setup on Azure DevOps, there's unless you need something specifically from GitHub Workflows and Actions, there's no need to migrate. Like Azure DevOps is still a big ecosystem. It's been around for a while under different names. It works well. It integrates well with Azure, but there's more and more integrations being made from GitHub to Azure. Like GitHub Workflows is also like, there's no GitHub cloud, right? There's GitHub pages, but that's about it. So GitHub is meant to integrate with any cloud environment or whatever you're using. It builds on a few primitives. For example, this was just an introduction, even though there's a lot of stuff to discuss, right? But GitHub also has this concept of, releases. There's a releases page. It has a concept of environments where you can have a setup of secrets and configurable values that you can reuse for certain things. It has a concept of deployments, and a deployment is not really tied to any specific cloud environment. It's just a way of representing that something is happening and something is currently being processed. So you could create a workflow that updated a so-called deployment in GitHub while you were running the commands to deploy to Azure or something. Then you could update the status of the GitHub deployment in a certain environment, and you could have another workflow triggered based on a deployment succeeded to the dev environment, so now it should deploy to another environment, something like that, or maybe it should file a report to some manager or something. And that's kind of the most interesting part here about GitHub Workflows is it triggers on all these different events. You might not notice that at first because it's just a CI/CD provider, isn't it? No, it's more than that, and you can automate all kinds of interesting things, and that's more difficult. I don't even know if that's possible in Azure pipelines. Like, can you trigger? There's a few triggers, but not as extensive as GitHub Workflows. They have similar concepts, right? The YAML configuration is very similar. They have tasks instead of GitHub Actions, but they're more difficult to implement yourself. GitHub Actions are for sure more flexible for you to create your own with little effort. And there's already 100,000 actions out there. Like there's another 100,000 tasks for Azure pipelines because they're pretty gnarly to implement and maintain.
Thanks for the insights.
I'd say that
Yeah, no,
the thing I miss the most is Azure boards, but the GitHub projects is also doing very well recently. And it's the same thing. Azure boards is part of Azure DevOps. It's not going to change much, but GitHub projects is where new things are happening. So if you want a different setup, try out GitHub projects. It's quite an amazing project or product already.
Yeah, I remember the last company I was working for, we just moved from GitHub to GitLab because they didn't have the CI/CD stuff in there. And as no sooner as we'd moved and migrated everything across, they come up with GitHub Actions. But yeah, no, it is quite nice. It is quite nice. But,
so
thank you.
Are there any questions?
That,
yeah, there's one from Tomas. Yeah, can you read it?
Yeah, sure. Sorry, I missed that. Yeah, is there a headless browser being installed here for the unit tests? And if so, which action is doing that?
Yeah, there is. It's Karma is using Chrome headless so that it can run in a GitHub runner because it doesn't have a desktop environment, but Chrome can run headless as well. Look into the code. It's in the Angular JSON configuration. There's a CI configuration for the test architect target. It's a configuration parameter. I think it's called browser, and the value is Chrome headless. Or maybe I'm remembering that wrong, and it's actually in karma.config. Some place there's a configuration value for browser, and it says Chrome headless. Yeah. So that's the magic part there. Yeah. And you can do that locally as well. You can run Chrome headless locally as well if you want to. It's faster than spinning up Karma with the actual browser. So if you just want to run the test quickly, Chrome headless is faster. Of course, if there is an error, you might want to debug using an actual browser when you're using Karma.
Yeah, I'm just in the process of migrating from Karma to Jest. Surprisingly faster.
Jest is completely headless, right? It runs on Node.js, so it doesn't have the concept of a desktop environment. So that runs fine on GitHub runners as well, without any special tricks.
Oh yeah. Okay. Well, I'd like to thank everybody for tonight. Jay, Lars, Aris, thank you so much. There is only one thing. As you've been talking and stuff, I have managed to pick some random winners for some prizes.
Nice.
So there we go. I have 2 copies of Aris's Angular Projects book. And then there's the Angular training certificate, the $30 voucher. And I've also got a copy of Sam Julian's DevRel, or Developer Relations ebook that he did a few months ago. So enjoy, yes, absolutely. But to claim your prize, as it were, you need to contact me on Twitter to get your details. As I say, the Angular project books are hard or are actual print copies. So Aris has kindly donated them for the prizes tonight. And I will need an email address for the other two. And then the Angular training company will then sort of set you up with a voucher for that one. And I think Sam will just email you a copy of the PDF file there once. But no, thank you for that. As I say, that's my Twitter handle on there. As I say, if Tamis, Fran, Mikael, or Werner, please do get in touch with me, and I will get your prizes out to you. But again, thank you for everyone tonight. Thank you, Jay. Just in time for lunch now, I should imagine.
Yeah, exactly.
Just in time.
And Lars, just in time. And Lars, thank you again. We get there in the end. Thank you for that. That was really good. And Aris as well.
Thanks a lot.
I will dig in. I will dig into that Angular CDK at some point, and might have a few questions for you.
I will be available.
Right.
Thanks.
Well, that's okay. Right. As I said, thank you for everybody. Thank you for everybody with your questions and bits and pieces. So yeah, hopefully we'll see you all next month.